Well, let's take a look at a little bit of Chapter 9, Managing Linux Processes. And then we're going to talk about test that I'm going to put out there. And I'm not going to spend entire time here going over material because I don't want to assign anything new beyond what I did last time, in addition to the test. Now, this is managing Linux processes. Categorize the different types of processes on a Linux system. We're going to view processes using standard Linux utilities, explain the difference between common kill signals, and describe how binary programs and shell scripts are executed. And we're going to get this loaded. Also, create and manipulate background processes. Use standard Linux utilities to modify the priority of a process. Schedule commands to execute in the future using the @daemon. Schedule commands to execute repetitively using the cron daemon. Now, for our Linux processes, we got a program, a structured set of commands stored in an executable file. If you take any kind of programming class like C, you write your C program and you compile it, and it creates an executable. This is executed to create a process. Process is a program running in memory and on CPU. Program in action, so something that's currently running. In the cases of maybe a C program, it might be so short you have a hard time catching it while it's still running. But there's longer programs you could write. Now, our user process is a process begun by the user on a terminal, and we've actually looked at that where we'd run different commands. Those are programs. Our daemon process is a system process, but it's not associated with terminals. So this is not something you're firing off, but it's just housekeeping type of applications for the system. We have a PID, process ID, unique identifier assigned to a process. Because if you're going to manage those processes, you got to have some way to refer to them. Child process is a process started by another process. So you can have a process that then fires off another one. Parent process, processes start other processes, the children. And then we got our parent process ID, PPID. And this is the PID of the parent process. Initial daemon has a PID of 1 and a PPID of 0. 0 refers to the kernel itself, which tells you something right there. The parent is 0, so the kernel is sitting there firing off these other processes. Again, when you think of that, these are just computer programs. So here's process number 1. It's got a PID and PPID, and then it's firing off 2 and 3. And both those have the PPID 134, which is the PID here. And same way here. This one fires off these two processes. And you see the PPID is 291, which refers to that. So that shows you the parent and child processes. Now our init daemon starts most other daemons during the system initialization process, including those that allow for user logins. So again, if you didn't have a little system program running, you couldn't log in. Login program starts a bash shell. The bash shell then interprets user commands and start all user processes. Each process on Linux system can be traced back to the init daemon by examining the PPIDs. These are a init that's firing off all these programs. Then this program here, this daemon, is doing the user login, which is the bash shell, and then a different user process here. Now we got the PS command, use view processes. Most versatile and common process viewing utility. No arguments, list all processes running in the current shell. And I didn't make this bigger, but there we go. That's a little bit easier to see. And this is what we're talking about. When you type PS, it comes up with these two here. And you see the bash is a process. So this shell that we're running right here is actually a process in the system. The PS is a process, which is interesting. It shows it because, well, I guess while it's showing it, it's running it. So I guess it makes sense it shows itself. Dash F, full option, more complete information, including the user identifier, UID, and the PPID, start time, CPU utilization. So PS-F. You see for the PS-F, the parent process of that is the bash shell here. Dash E displays entire list of processes across all terminals. Yeah, it's quite a few. So we do a PS-E and then pipe symbol more. And I was just looking at these first ones, assuming it runs it in order when it logs on. If I do a full one with that, you see these ones here. This parent process ID is the 0 that they're referring to, and same with this one. And then these are 2, which comes from this K thread D option here. Process flag indicates particular features of the process. Process date, current processor state of process. Most processes are sleeping S or running R. This column was most valuable to system administrators. And Trying to see if I can see it in this with this command. I'm not really seeing. Zombie process. Process is finished, but parent has not released the child process's PID. Defunct process. Process state is Z. I wonder. PS dash. Not very useful. Man PS. Select all processes. Dash F should be. Let's try big F. Maybe we'll cover it here shortly. They seem to have left part of it out there. Process priority, PRI, priority used by the kernel for the process. Higher value means lower priority. Nice value, NI, can be used to affect the process priority indirectly. Measure between -20, a greater chance of a high priority, and 19, a greater chance of lower priority. And size of the process in memory, SZ, is listed and measured in kilobytes. Some options to the PS command are not prefixed by a dash character. Okay, now this has got me. It's not even referring to that. Linux PS command show process state. Dash O. Let's try that. There it is. They didn't mention it, but you have to see the state. There should be some way you can see it on the list of everything. But if you do a PS and then you put in the PID, process ID, like 36808 or 37940, which isn't running anymore. But the 36808 is, because that's my bash, and you see it's got the state there. Interesting. Always nice when they don't give that crucial piece of information about how to see the process state. Unless I'm just woke up this early again this morning. I'm trouble sleeping. No, they don't mention how to run that. But again, we just did PS and then the number. And I wonder if we do PS and the, let's see, PS-F 36, or yeah, 36808. Just make sure that's not there. I'm just not seeing it. Okay, no, it doesn't appear there. Sometimes you have to kill a process. Let's see. Now, viewing processes, some options, the PS command are not prefixed by a dash character referred to as Berkeley style options. The A lists all processes across terminals. The X lists processes do not run on terminal. PS tree displays the lineage of process by tracing its PPIDs until the init. So PS tree. Let me look at my bash. Okay, not too much excitement there because we don't got much going on. Bash was just running through the bash shell as running PS tree. Got our dash E we looked at. We looked at dash F, dash L to produce a lawn list. Okay, here's a nice piece of information. So not to look at each one individually. If we want to do the lawn list, we do the L for lawn. Probably have to do an E also for everything that's running. But if I do an L here first, did I do an L? Okay, let's try it again. Okay, there's all the different items. Though I don't see status on there. Oh, there it is on the far left, S and R. Okay. So if I did E on that too, and this is what they're talking about, you can see what's currently running and so forth. Plays all processes running on terminals. Do not run on terminals. X. Clipboard, keyboard, mouse, printer. Well, think about what these all go with. These go with our GUI environment. So these are all of our processes that are running that, like they say, that do not run on terminals. Now, viewing processes, we have the top command. In this, displays interactive screen listing processes, organized by processor time. Processors using most processor time are listed first. So you see how it's currently changing? Rogue process, a faulty process, consumes excessive system resources. Sometimes it's written poorly. That's poor programming. Sometimes things just go haywire in computers, and you have to reset your computer. You have to reset a process. You have to reset your phone. So coding is not 100%, always accurate. My phone a couple days ago quit working. Quit being able to access data. And I never shut it off. And finally went to a website. They said, well, always the first thing you try to do is reboot. So I shut my phone off, turned back on, worked. It probably had worked 2 months prior to that, last time I shut it off. So sometimes things just go haywire. It'd be nice to say the reason why, and if you take the Introduction to Digital Design class, you'll learn reason why. Is everything is based upon voltage coming through, and so if you have fluctuations of your voltage, it depends upon whether it's like a 1 or 0 in the computer. So if your voltage isn't straight across, it varies, and there's a range. It goes with 0, and there's a range that goes with 1. Well, if it goes up maybe a little bit too far, and it should have been 0, should have been 1, these weird things happen. Top command can be used to change the priority of processes or to kill processes. Rogue processes can be killed immediately when identified. Kill command sends a kill signal to a process to terminate it. I'm not sure if I've ever done that in this utility. I don't think you can. Yeah, you can. If you just type K, it brings up, and you type which PID that it comes up with. The kill that they're referring to over here, this refers to an actual command. Okay, so if I'm over here, I did a Q to quit out of that. If I wanted to kill something, and I wouldn't know what to actually kill, VM tool. Let's see if I can kill that. Probably not, since I don't got any admin rights, but you never know. VM tool SD, I'm not sure what that is, but if I kill 1901, PS 1901, it's not there. I killed it. Now you can see the PS 1902 is that G application service, whatever that is, and again I could kill that. Hopefully what I killed didn't negatively affect, but I'm guessing it's the virtual machine tools. Okay, the kill process, kill signal, and the PID. SIG up, SIG up. Not sure how you say that. Hang up, SIG up, also known as the hang-up signal, stops the process and restarts to the same PID. If you edit the configuration file used by running daemon, daemon might be sent a SIG-HUP to restart process. When daemon starts again, it reads a new configuration file. Here's a SIG init. The signal sends an interrupt signal to a process. Though the signal is one of the weakest kill signals, it works most of the time. When you use Control-C, key combination kill a currently running process, a SIG-int is actually being sent to the process. SIG-quit, known as core dump. Quit signal terminates the process by taking the process information memory and saving it to a file called core on the hard disk in the current working directory. You can use the control plus the / key combination to send a SIG-quit to a process that is currently running. SIG-term, software termination signal, is the most common kill signal used by programs to kill other processes. It is the default kill signal used by the kill command. And SIG-kill, also known as the absolute kill signal, it forces the Linux kernel to stop executing the process by sending the process's resources to a special device called /dev/null. Now, trap. The ability to ignore a kill signal. The SIG-kill signal cannot be trapped by any process. Used only as a last resort because it prevents the process from closing temporary files and resources properly. And that's kind of true in any operating system. You have to be careful how you terminate something. In Windows, it'll oftentimes ask you if you want to wait till the process is done or it's still got a hold of this file. And if you go ahead and kill it anyway, you might cause some corruption, some loss of data. When a parent process receives a kill signal, parent process terminates all children before terminating itself. That probably comes across real well on videos, what I just said. To kill several related processes, send signal to a parent process, and kill a parent process in order to kill the zombie processes. Kill all kills multiple processes of the same name in one command. Takes the kill signal number as an option, uses process name instead of PID. If no kill signal is given, a default kill signal SIG-term is used. Can use top command to kill processes. While in the top utility, press the K key and supply the appropriate BIS. Pretty sure they meant PID. There's no PIS. I don't know what else to kill to actually test that, but I don't think there is one. Guess I could kill the top command, kill itself. If I type kill and then type in my top is PID number 38115. Send a signal. Okay, I think just enter. Yeah. I don't usually use top. I usually just press do the kill outside of this. It's like if I want to kill 38115, I'd do it through here. So we're no longer running top, so you don't see it there. Yeah, that should be PID. Kill signal. I think they mean this one here. Oh yeah, common administrative kill signals. Okay, so you pass in 2 to do this one, I guess. Okay. That's where I really wanted to stop there because I wanted to give you time to work on the test. And let me bring up. We spent a lot of time on Chapter 7 going over different commands and so forth. Somewhere in here is the if else construct, and you should know how to do that for the test. The test is a coding test, so you'll have to write your own script, shell script, using your emulator. Um, the the script itself is pretty basic in these. One of them just asks you to do a very basic if-else statement. You can just do echoes to print the results there. The test is 3 questions. It's worth 180 points. It is timed. I'm going to make it timed about 3 hours in this class, though. Because these are kind of tricky to get them to work quite right. The first one with the if else, it asks you to create a scenario using that. So it gives you a program to write. After you write your program, what you to do is I want you to copy that and paste it into Blackboard. Well, how do you do that? I've already brought down my VMware. Probably the easiest way is to do it all within your virtual machine, whether that's VMware or Oracle, whatever you chose to use. Bring up the browser in that, bring up Blackboard, and then you should be able to easily paste it over. Other ways you could do that, but you could just create your shells and then email them to yourself, and then through Windows do it. But anyway, then the other 2 questions, each one's worth 60 points, like I mentioned. The other 2 are based upon the for loop. So here's a for loop, and based upon the while loop, which is right here. Make sure you go through before you start taking tests and refresh your memory on the for loop and while loop. We looked at some examples in class. Make sure that when you're looping through the for loop and the while loop, you can actually access those variables as numbers. So, for example, you can multiply them or subtract them or divide them or add them or whatever. So if you do a little preparation up front with a for loop and a while loop, it should make the test go a lot easier. Otherwise, you struggle because getting it just right is tricky at times. If you remember in class, if we didn't have a space in the right place, it would not work. So go through, watch that video again if you need to, and practice on those 3 constructs, the if else, the for, and the while, and then take test. I don't normally like tests like this. This is part of our accreditation. All classes that have any kind of programming in it take this test, and it's kind of a measure of what are your students getting out of the program. It's a tool you can use to compare against past semesters, see if students are getting better or what exactly. Like I say, I'll go ahead and put the test out there for in this current week. I make it due on Sunday, so that gives you a little bit of time to practice and review and so forth. So I'll go ahead and stop the recording there.